Good afternoon. I'm going to say good afternoon because I'm speaking from the UK and our speaker is speaking from India. So it's good evening. And if there's any people from the US, good morning. The session that we're covering today is going to be presented by Vishal Gupta, who's a solution architect, works for IBM System Labs. Myself, my name's Jeff Eggleston. I work for IBM UK. I'm on the Z platform. I'm a technical specialist. The topic that's actually going to be covered is real-time data sharing via Z in-memory cache is what's going to be covered. What I've been asked is if there are any questions, could we actually take them at the end? Raise your hand on the where you've got the react button. If you press that, then what I will do is unmute you and you'll be able to ask questions. If you don't want to do mute, or if you don't want to come on, then by all means type it in the chat. Quite happy for that. Before we kick it off and I hand it over, the one thing that GSE feeds on is feedback. So one of the things that I would actively encourage you all to do is once the session's done, could you please fill out the feedback? The session is AE. It's very important because this will also help us basically determine what presentations we do in the future. And then finally, what I would say is if you go onto the agenda, you will find that the presentation has been loaded up, so you will have access to that. So without further ado, I'm going to hand it over to Vishal, and thank you very, very much. Over to you, Vishal.
Thank you, Jeff, for introducing. Welcome everyone to my session. So as Jeff mentioned, right, the title of the topic is real-time information sharing via Z in-memory caching. So what I will be talking about here is how we can share the real-time information between IBM Z and hybrid cloud environments. So we'll talk more about it, that how we can do that. So before jumping onto that or jumping into the solution which can tells us how we can share the information, first let's look at the industry shifts which are happening across the globe. So industry shifts for digital transformation, modernization, ecosystem expansion, all these different industry shifts requires agile interactions with core systems, which are running on IBM Z mainframe. So, and to navigate to these industry shifts, all the enterprises has their own needs, and they do face many challenges when they think about meeting those needs. So now let's look at those needs and the challenges which enterprises are facing to navigate to these industry shifts. So to start with, we need a real-time and event-based interactions with our core systems running on IBM Z mainframe. And the challenge in this need is how we can share that information at scale. If I talk about inquiry traffic, so we have increased inquiry traffics which are coming to our core system of records, and that too with unpredictable volume. And the challenge is how to handle that inquiry traffic, that workload in an optimized way so that high throughput and the low latency can be achieved. So moving to integration perspective of it, having an integration between mainframe and cloud application. So nowadays enterprise doesn't want to have their integrations at a custom data extract levels. They want to have an integration so that their cloud application developers can access the information from mainframe as a self-driven approach. They don't want to depend on those custom data extract, which are very inconvenient for their developers to read and understand. And coming to the enhancement into the digital and mobile channels, all enterprises are focusing on enhancing or giving a better customer experience in the digital and mobile channels. And the best and the thing which they wanted to achieve in this is consistency of information. They wanted to make sure whatever they have in their system of records is being shared across the enterprise and all the mobiles and digital channels in their enterprise. So, but still the challenges which they are facing. So let's see how they are interacting or how they are handling these challenges within their current capabilities. So in this particular chart, what you can see at the bottom, we have a depiction of IBM mainframes, transaction and batch applications. So these are the applications which runs their core business applications, which generates a very high volume and high value data. And on the top, we have a depiction of various public clouds where all the cloud native applications are hosted. And to have an interaction between these two environments within the current capabilities, we have seen a trend. Enterprises are using these two routes. The first route is making a copy of their mainframe data into their data warehouse or data lakes or other data stores with the help of standard ETL or CDC processes. And then they have their consuming cloud applications to come and access the data or make a further copy of that data into the clouds and use it from there. The another route which we have seen is the direct API routes. Cloud applications are coming to mainframe subsystems, transactional subsystems, CS or IMS, hitting the transactions and getting the response back. So these both routes has their own advantages or benefits, but still it doesn't serve their complete purpose. So if I talk about a reporting kind of use case where we are okay to have a point in time data. So the replication of data which we have made into data warehouse or data lakes, those are good to have serving the reporting kind of use cases. But if we talk about the other challenges which they are facing in this particular interaction is they might need a real-time information, but what they get a stale information. They are interested into having the ordering of transactions. So I think they would like to know what are the order of transactions which are happening in the mainframe so that they can trigger their downstream applications based on those eventing. Cloud application, the consuming applications are interested in composed information. So when I meant to say the composed information, that derived information, as in kind of example, balances, account balances, these kind of informations we never store in our data stores. Hence, they never get replicated into the data warehouses or data lakes. And what cloud application has to do is they have to embed the same business logic again, which they have in their mainframe applications to come to the derived fields. And if I talk about the second route, the direct API route, in this route, each and every type of traffic, irrespective of inquiry traffic or update traffic, they have to interact with the core system. They have to interact with the transactional subsystem. It means each and every request is contributing to MIPS. So there they face a challenge of cost, and they are looking for how to optimize the cost by moving the inquiry traffic to somewhere else. So the challenges which they are facing in this current capabilities, so we have tried to serve that with the help of IBM Z Digital Integration Hub. So IBM Z Digital Integration Hub has introduced to address all those challenges. So if I talk about those one by one, how IBM Z Digital Integration Hub, also known as ZDIH, helps us. So talking about the real-time information, with the help of ZDIH, we can share the real-time information with our cloud application, as this is a cache-based application, and we can have required information stored into Z Digital Integration Hub so that our consuming applications can access that. We'll talk about more on this, how this integration happens and how we can access it. So in the upcoming slides in this session, we'll talk about all of them. So, but let's see which all challenges it is addressing. So it gives us a flexible information model. So when I am referring to flexible information model, it's not about we can only pass on the data to the Digital Integration Hub, which are stored in our databases or data stores. We can have those derived and composed informations passed on to ZDIH and can have our consuming application consume that. It gives us a TCO advantage. And how it does that, this Z Digital Integration Hub, it runs within JVM in USS. So all the workload which it is serving is zip eligible. Hence, we are not contributing to MIPS and we get the TCO advantage. So moving next, let's look at some capabilities of Z Digital Integration Hub. So Z Digital Integration Hub capability helps enterprises in modernizing their applications and give them a way to adopt the hybrid cloud architectures. and how it helps us in adopting the hybrid cloud architectures by its capabilities. So to start with, sharing the current information from core business application across the enterprises. So the applications which are running on a different platform, such as their public clouds, private cloud, their on-premise x86 distributed server. What they want is they want a real-time information from mainframe in those environments. And how they can do that, ZDH helps there. If I talk about the faster time to value, the hybrid cloud developers who are working on making a new cloud-based application, but their input is dependent on the information or the data which is in mainframe. And what they don't want is they don't want to have it dependent on the custom data extracts, because that is not easier for hybrid cloud developers to understand it, because our layouts might have a reoccurs clause. It could have a redefine. So all those type of layouts and files is very difficult for cloud developers to understand it because they don't have those skill sets. So to get a self-driven approach to read the information from mainframe so that they can have their application developed faster and they can faster time to value and have their innovations quickly done. So it helps us in those scenarios. And coming to the cost optimization factor, as I did mention in the previous slide too, the workload which ZDH is serving is replenishable. We can have all those inquiry traffic, all those requests to fetch the information served from ZDIH, which is replenishable. Along with that, we can easily separate the inquiry traffic from our update traffic for cost advantages. So coming to another key capability is scalability. So it can help us sharing the information with a very high throughput and low latency without impacting to core systems or even without interacting with our core systems. So these are the key capabilities of Z Digital Integration Hub, which helps us sharing the real-time information across the enterprise. So now I would like to talk about the components of Z Digital Integration Hub and an overall flow, how information flows from our mainframe to our end consumers. So what all different components are part of this architecture and how it helps us sharing the information. So to start with, you guys can see my screen. In this screen on the left-hand side, in the purple, we have a depiction of mainframe applications. In the green box, we have a depiction of IBM Z Digital Integration Hub. And at the top, we have a consumers who are interested to get the information. So as in first component, we have a core system integration. So what we need to do is this application, this integration, this core system integration happens at application level. So we need to understand one point here is this integration doesn't happens at a database level or at a files level or at a data stores level. This integration happens at an application level. To give an example, our transactional applications like CICS or IMS applications, this integration happens at that level. So we capture the relevant information which is needed in the caches and by our consumers. We capture that information from our Z applications and pass them into the log streams. So the log stream is the component which I am referring here. These are not the CICS or VSAM or our other data stores log stream. These are the ZDIH specific log streams which we have to spin up as a part of ZDIH onboarding. So the relevant information gets captured from our Z applications like CICS or IMS, and that information gets passed into the log stream. So this integration is a level 1 integration between Z applications and log streams. So the next component here is the caches itself. So we are calling it ZDH caches. You can see at the bottom, right now we have a depiction of 2 caches. So by default, these are in-memory caches, but these can be persisted on disk if needed. So might be many times because of a backup perspective, we do have alternate caches so that we can have a backup available for our in-memory caches in the cases of caches. And if we talk about more about ZDH caches, these are not the flash caches where we have written something at a record level. So the information which gets stored in these caches are at a key value pair so that the standard interfaces can easily come and access the information from ZDH caches. And if I talk about the number of caches or a lifespan of caches, it varies based on our need, based on our business need. So like in this scenario, I have depicted 2 caches, but based on our needs, we can have n number of caches available. And if I talk about the lifespan of caches, it's again based on our requirement, our business requirement. So in this scenario, if I take an example, the account caches that we would like to persist for a longer duration, and those are needed every time. And if I talk about the transaction caches, those transaction information which we might like to capture for days or weeks or months, not for multiple years. Again, we can set a lifespan of these caches as per our business needs. So moving next, the next component as a part of Z Digital Integration Hub is the Management Center. So this is a GUI interface to IBM Z Digital Integration Hub. It helps us monitoring the ZDIH caches, ZDIH nodes. It also gives us a SQL-based interaction to the caches. We can run the SQL queries from ZDH Management Center to pull the data from ZDH caches. And it can be deployed Linux, Unix, or Windows, any environment which is closer to our Z Digital Integration Hub. So next component in the list, we have the ZDIH applications. So why, and these are the Java-based applications. So why Java applications? Because we wanted to make sure the available skill set which we have in the market, we wanted to make sure these ZDH applications are spinned up in those languages so that it will be very easy to maintain by the enterprise. So what this ZDH application does is they read the information from logstream, which has been written as a part of our first integration. When our Z applications and log streams are integrated with each other and the relevant information was written into the log stream. Now these applications, these ZDH applications reads the information from log stream and push them into the ZDH caches to make them up to date every time. So this is our, and we'll talk about more on this in our upcoming slide. So how this application gets generated and what we need to do that. So all those information we'll talk more in our upcoming slides. So the next component here is the ZDH development kit. So ZDH comes with its development kit for helping us accelerating onboarding the ZDIH. It comes with various interfaces and SOA templates, which helps us bringing up the ZDIH components very quickly. So we'll talk more about the ZDH development kit as well, at what all places it helps us. Just to give you an example at this moment. So this Java applications can be auto-generated with the help of ZDH development kit. The initial integration, which was between Z applications and logstream, can also be accelerated with the help of templates which are provided with ZDIH. So the next component here is our standard interfaces. So standard interfaces means ZDIH supports standard interfaces to interact with those caches. Our consumers, our consuming applications can interact with these caches as a REST-based interaction. They can have a JDBC-based interactions. They can have an event-based interaction. So we'll talk about more on these two as well. But if you see, we are supporting push and pull both kind of interfaces to the ZDIH caches. Okay, so this was all about the ZDIH components and its flows. If I take 10 seconds to explain the flow one more time. At a first attempt, what happens here is our mainframe applications, CICS or IMS kind of applications, gets integrated with logstream. It writes the relevant information into the log streams. And as a second step, our ZDH applications reads the data from log streams and push them into the ZDH caches to make them available for our end consumers to use it. So all these things happens within sub-seconds. Okay. So moving to, so let's talk about more on core system integration. So that was our first integration point. So as I was taking an example of CICS. So many times what happens, our logical unit of works span across the transactions. We don't want to push the records into the log streams at a first attempt. So what we would like to do is we can use a Kix TSQ or containers and channels technology to make the right logical unit of work submitted to log streams at the right time. And if it is a commit, it gets written into the log stream. If it is a rollback, then those information doesn't get written into the log stream. So if I talk about these pre-built templates, so these are the templates which comes with ZDH development kit. It helps us integrating these applications with ZDIH. So this integration, this trigger to log stream happens at our application exits. In the case of CACS, you can take an example of CACS exits. So at that time, the information get pushed into the log stream, and it supports CACS and IMS based options, so that our ZDIH caches are kept up to date, and that too in real time. So here, more on the low code approach which ZDIH provides. So it is more on that developer kit which I was referring to. So let's see how it helps us. Those ZDIH applications which I was talking about, which reads the information from log streams and write into the caches, can be generated with the help of developer kit. So developer kit comes with one of the module called application generator module. So that application generator module needs two inputs to spin up this Java application. The first input is it needs a COBOL layout of a log stream in which relevant information was written, so that we know which information has to be read from the log streams and in which format it has to be written into the caches. And the second input this application generator module required is the config parameters, so that we can create a robust Java application. So once these two inputs are provided to the application generator module of developer kit, it generates a Maven Java project. And then that Maven Java project can be imported into IDE of enterprise choice and can easily be integrated with the DevOps pipelines to maintain it easy. And the Java applications which we generate, these are not the black box kind of applications. Those can be edited as needed. A business logic can be inserted, can be added into the Java application as per our business requirement. But if we wanted to have the standard sync, we wanted to flow the information, whatever is in log stream, and we wanted to push into the caches, no need of modifying this Java application. This can be used as is. So this is the low code approach that help us in adopting the ZDIH very quickly. So now I will talk about the interfaces, those standard interfaces which ZDIH supports. So here you can see the name REST API, JDBC, Kafka. So I'll start with Kafka. Right? So when we have an eventing kind of need, we wanted to trigger something in our downstreams as and when something happens on mainframe. So what we can do is we can utilize the Kafka integration pattern. So ZDIH comes with a Kafka connector, which helps us creating a pipeline between the ZDIH caches and Kafka topics. So how it works is, as and when any message comes on ZDIH caches, that Kafka pipeline push that message to the Kafka topics for our downstreams to act. So in this way, we can have event-based downstream triggers or event-based use case can be served using this ZDIH. And if I talk about JDBC now, and to give an example, our business analyst would like to query the information from caches for their need. They would like to access this query from their choice of SQL clients, as an example, dbeaver. They would like to access the ZDIH caches from their dbeaver. They can establish a JDBC connectivity to these caches and can fetch the information. Similarly, if the other tools which supports JDBC can also be integrated with ZDIH caches to access the information. And if I talk about our hybrid cloud native applications, those applications can use the REST API method to interact with the caches to fetch the information. So these are the various integration patterns, integration standard patterns which ZDIH supports for our consumers to access the data. Okay, so here I would like to talk more on monitoring perspective. I did mention about the ZDIH Management Center. That Management Center helps us monitoring the caches, the memory and heap utilization, the node configuration, the status of our server, and it also gives us a SQL interaction to our caches. But our monitoring capability is not only limited to ZDH Management Center. What we can also do is we can use our existing IBM OmegaMon for JVM on ZOS product to monitor the performance of JVM, which is used by IBM Z Digital Integration Hub, as this ZDH runs within JVM. And we can also monitor the ZOS resources which are used by ZDIH with the help of our standard IBM ZOS tooling. As an example, SMF records. So the log stream, the ZDH log stream which we are using, it generates its own SMF record number, which can be used for monitoring the log streams. So in this way, we can integrate. There are many other tools which can be integrated with ZDIH for monitoring purposes, and we can talk more about this. You guys can reach out to me offline so that we can talk about all those monitoring capabilities if it is really needed. But yes, a point is it can support not only ZDH Management Center, the other monitoring tools can also be integrated with Z Digital Integration. Okay, so I just take 1 second, please. Thank you. So this was all about ZDIH. That what is ZDIH? How does it work? What it does, how it helps us in sharing the real-time information from our mainframe to our hybrid cloud applications across the enterprise. Now we look into the use cases of ZDIH, and let's see what are those. So to start with, I will start with a industry standard pattern, which is CQRS pattern. So this is also known as Command Query Responsibility Separation pattern. So what this pattern say is, we need a way to route our inquiry traffic away from our core system and serve them from somewhere else, so that we can segregate them and we can reduce the TCO, we can faster the response for our inquiry traffic. So usually within the current capabilities, what enterprises might be doing is they are making their homegrown ODS and redirecting their inquiry traffic to homegrown ODS, or they are redirecting or serving that inquiry traffic from their replicated data. So what we say is, with the help of Z Digital Integration Hub, that inquiry traffic which needs a specific information from mainframe can be rerouted to Z Digital Integration Hub, and all the insert and update traffic can go in the same route to mainframe subsystems with the help of APIs. So to give a business example, when we need intraday balances for current accounts and saving accounts from inquiry perspective, we can have that information in ZDH caches. When we need a real-time information about wholesale or retail payment entities, we can utilize ZDH for that scenario. So credit or debit card activities, so we can utilize ZDIH for those scenarios. If you talk about the benefits of implementing this optimized CQRS pattern, that we are not interacting with our system of records, we are not impacting our system of records, we are still getting the real-time information at scale, we are getting a composed information, the derived informations which we can also pass on to ZDH caches can be accessed by our inquiry traffic. We get the TCO advantage because now we are not going to our mainframe subsystems and contributing to MIPS. That traffic is getting served from the Digital Integration Hub. So this is the standard pattern, industry standard pattern, which can be optimized with the help of the Digital Integration Hub. So moving to the next use case. So here this use case says when we wanted to share the intraday running balances for our consumers. So let's look into this use case now. On the left-hand side, we have a representation in purple, standard mainframe application, a banking application, which has a capability of creating the accounts and performing the debit or credit transactions on those accounts. So what we can see here is on the right, in the middle, we have a green box, IBM Z Digital Integration Hub with 3 ZDIH applications running. So let's look at one by one why these three applications and how it is serving our purpose of sharing the intraday running balances for our consumers. So the first applications, CDH applications, which is for reading transaction informations and refreshing the caches. When I'm saying transaction informations here, I'm referring to my online transaction updates. So as and when any online transaction happens on mainframe, with the help of Z Digital Integration Hub, that relevant information gets captured and written into the log stream. And this ZDH application is reading the information from log stream and inserting into the caches. Because this is information, this is the record related to transaction. Hence, we are doing an insert into the transaction cache. But if you can see here another flow from this application to account caches. And the reason for that is, as and when any transaction happens, there is a change in current balance. So what we are doing at that time is, we are updating the account level information's current balance, so that account level information can have the running balance and can have the current balance after that transaction. If we talk about the next application, which is here in this Digital Integration Hub, this is for priming the caches post-batch. So all the transactions which happens are not online transactions. There are many memo kind of transactions too that takes place at the midnight when we are running our mainframe batches. So how we can have that information sync with our Z Digital Integration Hub? So what we can do is, once the batch is completed in our mainframe, we can trigger our ZDIH application to priming the caches at the start of the day. And post that, as and when any online transaction happens, we can keep them up to date so that latest running balance can be accessed by our consumers. You can also see there is a one flow for our lookup files. So many times what we need is, we need a consolidated view, and this lookup files also we needed to get the information from a one single place. So what we can do is, we can also load our lookup files into the caches. So in this way, we can have our intraday running balances available for our digital channels, so all other consumers available in the account caches. Either it could be a memo kind of transactions or real-time online transactions. All transactions are considered into the consideration for having these caches up to date. So this is another use case for the Digital Integration Hub. So if we see in this use case, we are talking about integrate with multi-cloud or edge cloud. So what we are saying is, we can expand our existing operational data stores. What you can see here is, in this particular chart, in the blue box, we have a operational data store depiction. So if we don't think about the ZDIH, enterprise might have their operational data stores in which they are storing their all known IBM Z data for their consumers to access. With the help of ZDIH, what they can do now is, they can expand their ODS. They can have IBM Z data part of their ODS. If you can see here is account activities, loans by product, the real-time transaction history. So all these type of informations can be made available in the ODS with the standard interfaces, so that our consumers can access it. So this ODS can be on multi-cloud or edge cloud. So if you see here, we are again using the standard interfaces to interact with ODS. So we can also set up a Kafka event so that this ODS gets updated as and when something happens in ZDIH caches. So this is one of the use case where we can expand our existing ODS to IBM Z information as well. And apart from that, the other workloads can also be served in the same manner. Like they can also come to this Digital Integration Hub directly, which are not going to ODS. So this is another use case of the Digital Integration Hub. So here we are referring to two-way communication to and from cloud. So don't confuse it with our two-phase commits. ZDIH doesn't support updating the information back to our mainframe databases or files or different data stores. Here we are talking about the two-way communication of information with the help of Z Digital Integration Hub caches. So let's see how we can do that. So we have two flows here. If we talk about the first flow, where what we are doing is we have integrated our mainframe with ZDIH for passing the account information so that our hybrid cloud applications can come to ZDIH and get the account information. So this is a one-way information where we are sharing information from mainframe to our hybrid cloud application. And if we think of expanding the scenario where we have a risk scores calculated in our hybrid cloud applications, and we want our mainframe applications to read those risk scores. So what we can do here is we can also write, or we can also update our ZDIH caches from our hybrid cloud applications for a field which is not available in mainframe. We can have a field populated as a risk scores from our hybrid cloud applications. And then our mainframe applications, which needs those risk scores for their own business purposes, can come and access that information via JDBC. If we talk about the second flow, here the one-way flow is same. Account information is shared and our hybrid cloud applications are accessing that account information. But to share the risk scores back to the mainframe, we have another options here. What we can do is we can spin up another cache which can hold this risk scores, and we can attach an event listener to that cache. So what that event listener will do is, as and when any cloud application writes a risk scores into a new cache, into a response cache, that information will also get written into the ZDIH specific log stream. And then a mainframe applications can access those ZDIH log streams for their need. So in this way, we can share the information in two-way with the help of ZDIH caches. So this is one of our ZDIH use case. So similar to that, now you can think more that at what all places we can utilize ZDIH Integration Hub for sharing the information. So I just picked 4 of them. So we had many use cases around ZDIH Integration Hub. So now if I talk about the M&T Bank, so this is our anchor client and the public reference for ZDIH Integration Hub. So M&T Bank has started their journey with ZDIH Integration Hub with 2 caches. With the help of those 2 caches, they wanted to share the information with their hybrid cloud application to mitigate the risk and the potential fraud by giving the information in a very quicker manner within sub-seconds. They have started with those 2 caches. If we talk about their current scenario, they have more than 10 to 15 caches running in their production for various different use cases. They have also used ZDIH Integration Hub for improving time to value. So when I'm saying time to value is hybrid cloud data-driven applications which they are working on. Now their developers are accessing the information from ZDIH Integration Hub to deliver those applications faster. They have seen a 40% faster time to market. Their business analysts are also able to respond to the customer issues in a faster manner because now they have access to the composed information. They no need to depend on their own calculations. They no need to depend on other applications to give them the composed and derived information. They can directly go to the caches with the help of their own SQL clients, pull the data and resolve their customer issues. So now I will move to demo. So in this demo, so before starting with the demo, I will just explain which all components are part of my demo. So you can see here the core banking deposit processing, which is written in the middle. So this is my mainframe CACS COBOL based application, which has a capability to create new bank accounts and to handle debit or credit transactions corresponding to those accounts. So this CACS COBOL based application has also been exposed via API to the external consumers, external users to trigger the workload. So you can imagine it like a mobile application or a web application interacting with mainframe CACS COBOL application with the help of APIs. And on the right-hand side, we have integrated this CACS COBOL application with our ZDIH Integration Hub for sharing the information. So that information gets written into the log stream, and then our ZDIH applications reads the information from log stream and insert or update according to the workload into the corresponding caches, which are account caches and transaction caches. So this Java application and account caches has been created with the help of ZDIH development kit. And on the extreme right, you can see our consumers who are ready to consume this caches. And in this particular demo, we are considering a dashboard as our consumer, which is consuming this information from these caches to show what is happening within my applications around the various accounts and the transactions. So now let's look at this. So first, what I will be doing is I will be simulating a workload to create the new accounts and a corresponding transactions to each account. So here I am taking a number of 50,000. So it will trigger a 50,000 new account creation request to the mainframe CSS application. And now I will also be choosing the number of transactions which I wanted to trigger corresponding to each account. So 21 I have chosen for individual transactions, and this 506 number I have chosen for my business transactions. So upon submit, this workload will be submitted to CICS COBOL application. You can see in the console, this is the response from our CICS application. Accounts created, transactions created. You can see the information. So here, this is my consuming application. This is my dashboard, which is driven based on the ZDIH caches. You can see in this particular chart, we have all the transaction listed, which has amount greater than $500. And these are the two consoles, which you can see on my screen. On the left-hand side, it's an account cache console. And on the right-hand side, this is the transaction cache console. So what it is showing us is these are the information which are getting written into the caches. And you can see in the account caches, we have account numbers, transaction time, opening balance, current balance. And in the transaction caches, we have other fields like transaction types, running balance, cache timestamp. So these information can be used as needed by our consuming application. So the dashboard which I was showing, this is just for the reference perspective, that how we can utilize these caches to share the information at real time. So now let's try to do a deep dive at a one level down. So here in this dashboard, I have selected 3 accounts. And now you can see in a real time how the balance on the left-hand side is varying for that particular account. And on the right-hand side, the last 9 transactions, 10 transactions corresponding to each account and their corresponding amount. So these are varying on a real time. So because our workload, which we have simulated, has a huge amount. So you can see how this information is still giving us a real-time view of our account caches or our transactions. So this ends my demo. So here you can again see, right? So these are the transactions which are greater than $500, and we are just seeing those moving based on our transactions happening in the background. Okay, so here comes our Z-Teacher Integration Hub benefits, which I have also covered in one or other way in our other slides. But let's take a glimpse on those benefits. Valuable IMV application and data can be shared in real time with various consumers which are on cloud or on premises. It supports a flexible information model. We no need to depend on the schema of our existing databases, that we can only share that information which is available in our databases. We can share beyond that, we can share the aggregated or composed information with downstreams. The standard interfaces which it supports, REST, JDBC, Kafka, means push and pull both kind of interfaces. Interactions can be happened with Z-Teacher Integration Hub. The next is the low latency. As this is an in-memory cache-based solution, it has a very low latency in sharing the information with our consuming application, and it can still meet the same SLAs which are required by our cloud applications. So we can separation of inquiry from update. So this is that CQRS pattern which we have talked about. We can segregate our inquiry traffic from our update traffic and take the benefit of ZIP. Reducing the development time, like the self-driven approach of the Digital Integration Hub, helps our developers to develop their applications in a faster manner. So these are some pointers which are around good fit use cases or not good fit use cases. So let's look at this not good fit use cases first. So move all US core system data to the cloud or another environment. So ZDIH doesn't fit or doesn't say that when you have a need to move all the US core system data to the cloud, it doesn't fit in this particular use case. If we talk about when our ad hoc query interaction needs access to the all core system of record data, not the subset of that data, ZDIH doesn't fit there. When we have a need to stream all the data off the platform, it doesn't fit there. It doesn't support cache all the data from a system of records in ZDIH. It doesn't support means we don't say that ZDIH is this is the best use case for ZDIH when you have a need of all the data from your system of records. We don't AI ML model training that requires access to the granular level of raw data. ZDIH doesn't help us because ZDIH works on subset of data. It works on composed and aggregated information from our raw data, which is needed by our consuming application, so that they no need to embed the business logic against in the consuming applications. On the left-hand side, if we come to the good fit use cases, very quickly, compose aggregated information, implement optimized CQRS pattern. Hybrid cloud applications are facing a latency issue. They need information more real time. We need an event-driven approach of information flow. Combination of batch and online information, like I was referring to the priming the caches at the midnight and then online transactions takes care of making that running balance. So information sharing across multiple US applications. Reuse composed information by multiple cloud consuming applications. The same composed information which has derived once in our mainframe, our consuming application no need to spin them, no need to build or embed that logic once again. So these are the few good fit use cases, not good fit use cases around ZDIH. So here I will take a pause for questions.
Vishal, thank you very much. It doesn't look as though anybody's coming forward with questions at the moment. To be honest with you, I found it very helpful. It certainly aided my understanding of the Digital Integration Hub, and particularly with the hybrid cloud and using things like OpenShift and AWS. The question I have for you is, how long does it take to actually get it implemented from start to finish? Are you able to give us a feel on that? Because I felt, unless I missed something with what you said.
See, so Jeff, there are multiple factors which has to be taken into the consideration to see how much time it will take it to onboard. So those scenarios are like finding a right fit use case, starting from finding a use case and then deciding the infra which is needed for that, all the prerequisites, and all those things takes time. But when I'm saying it takes time, it means because we have to make a decision that implementing of ZDIH helps our clients for their needs. So once those decisions has been made, post that, I would say the POC can be done within 4 to 6 weeks for the Digital Integration Hub for the identified use case. So that's what I would say at this moment.
Okay. And in terms of getting it in production, are we talking 1 month, weeks? Can you give a feel on that? I'm sorry to push you on that.
So Jeff, again, I
know it
would
depends.
like to answer this question, because it depends on various factors. So which customer we are talking about, what are their processes? Because the technical thing doesn't take much time, but the processes in conjunction with technical things takes time. So again, it varies on customer to customer, use case to use case, number of caches required for our use case, number of applications required for our use case. Are we looking for some customizations in our applications, or we are good with our standard application? So all those parameters needs to consider to come up with a estimate for that.
Okay. So one thing I will say with you, I was very impressed with that one foil where you showed use cases and not use cases. I was very impressed with that. So really, really, really good. So very good. I'm going to see if there's any more questions. There's no more questions. So I think what I'm going to say is, first of all, thank you very much. Very informative. And I take it if people want to ask you questions, it's on. I notice your emails are there, and basically they can fire an email over to you at
Definitely.
IBM. So
definitely, people feel free to reach out to me.
Yeah, and what I will do now is I will start. I'll finish where start where I finished, and that is, please, can you give feedback? The session is AE. And if you don't want to type all that out, all you do is go into your build your own agenda and actually click on it on the bit where it says give some feedback, and it'll go to it automatically. So I am going to propose bring it to a close, unless you've got anything else to say, Vishal.
So team, if you wanted to give feedback right away, you can quickly scan this QR code as well. So that might be even more faster for you. But thank you so much, everyone, for joining the session. Feel free to reach out to me. So Jeff will share my email ID, or you can reach out to me on that. Thank you so much, everyone, for joining my session. Thank you, Jeff.
Thank you very much. Cheers.